Hello guys, this is Akash. Welcome back to this YouTube channel Nursery with Lecture. In this video, I am going to discuss another chapter, that is limits, in the top 10 question series for JEE Advanced 2023. This is the first question, but before going to this question and in this video, I want to say something, that is thank you guys for supporting me and subscribing to this channel. And if anyone is new to this channel, subscribe to this channel and also hit the bell icon to receive the notifications, as well as join the Telegram group for receiving the updates for the JEE Mains and Advanced exam related, and also any other questions you can ask in the comment section. And that's it guys. Now let's get into this video and discuss the first question. This is a limits. This limits has at least 1 to 2 bits in the JEE Advanced. So it is really important to discuss the limits. That is the reason why I kept it alone. If you see the continuity and differentiability, those are also important, but those are mixing concepts, that is continuity, differentiability and differentiation. These three can be merged into single chapter. For JEE Advanced, for JEE Mains, there can be 3 questions: continuity 1 question, differentiability 1 question, and differentiation 1 question. But in JEE Advanced, there will be a mixing of concepts. So for knowing the concepts, the limits concept is really important. So that is the reason I am taking separately this session. So now let's get into this video. And this question has a specialty because this question came in JEE Advanced 2022, which I written and I solved this question. JEE Advanced 2022, this question, very simple question only. When you see it, it will be really large. So what we have to do in limits, only one rule. To solve any question, what is that rule? What is that rule? Find which indeterminate form it is. Which indeterminate form it is, and apply suitable method. What does it tells? And they are saying, just see what is it. It is a form, whether it is 0 by 0 or it is infinity by infinity, or it is 0 into infinity, infinity minus infinity, or it will be infinity power 0, or it will be 0 power 0, or it will be 1 power infinity. Among 7 indeterminate forms, which indeterminate form it belongs? So when they given limit extending to infinity. When we keep limit extend to infinity, then when we are checking the numerator. When x is 0, it will be 1 minus. When x is 0, it will be 1 plus. When x is 0, it will be 1, and it is 1, and it is sine, it will be 0, it will be completely 0, divided by, when x is 0, it will be 0 into sine 0, it is sine 0 only, that is 0. So this cancel, so it will be 0 by 0 form. So for 0 by 0 form, what we have to do? For 0 by 0 form, we have to apply 3 methods, that is factorization, second L'Hopital, third rationalization. But depending upon the problem, we have to choose. Here L'Hopital has a chance, but we are avoiding the L'Hopital. Why are you going to say? Factorization we are also avoiding, rationalization we are also avoiding, because there are no rational terms. So 3 methods are failing here. There may be success at the 1 method, that is L'Hopital is definitely work here, because 0 by 0. But if you are applying, it is very difficult to find the answer. That is the reason I am rejecting these 3 options, and now I am applying the 4th method, that is important method, that is expansion. So this problem can be converted as like this: beta equal to e power x cube. What is the e power x expansion? E power x expansion is 1 plus x square divided by 2 factorial, and so on. So I am writing here 1 plus, what is x here? X is x cube here. You have to observe this term. X is x cube here. Plus x power 6 divided by 2 factorial. There is no need to take x power 6 divided by 2 factorial, because if you observe carefully the denominator, I am going to write here x square into x square. What is, when limit is extending to 0, what is sine square x divided by x square? It is 1. So I can completely rub this thing. And what is x into x square? It will be x cube. So in the denominator, if it is x cube, we have to take up to x cube times only. So I am taking x cube times only the numerator. Minus, and it is binomial approximation. I can write 1 minus x cube in whole power 1 by 3. I can write as 1 minus x cube by 3. So it will be 1 minus x cube divided by 3 plus, because when 1 minus dabba, that is box, when this box is tending to 0, I can apply the binomial approximation and I can write x cube divided by 3. It is over now, and here again it is tending to 0, because x is tending to 0, this is also tending to 0. So I can write here 1 minus x square divided by 2 and here minus 1. And what is sin x expansion? Sin x expansion is x minus x cube by 3 factorial up and so on. But there is no advantage of taking more than that, divided by what? X cube. Now if you observe carefully, beta equal to 1 plus x cube minus 1 plus x cube by 3 plus 1. Here plus 1 minus 1 is cancelled, and when you multiply these things, you will get minus x cube divided by 2. And here it is also no need, because it is greater than x power 3. There is no need. After all, what we write, it is correct. Divided by what? It is x power 6. Now beta equal to, these two will also get cancelled. Now top x cube common, 1 plus 1 by 3 minus 1 by 2 divided by, here it is x cube. So x cube is cancelled completely. So beta equal to how much? Beta equal to LCM 6 and here 3 plus 2 minus 3. So beta equal to, once again, one second guys. Sorry. Here it is beta equal to, LCM is 6 here. So it is 6 here plus 2 here minus 3. So what it is? 8 minus 3 is 5 by 6. So beta equal to 5 by 6. What they ask is 6 beta. 6 into beta. So 6 into beta, it is 5 by 6. 6 cancel, it will be 5. So what is it? What is the answer? 5. We have to solve like this. You have to take the expansions of every term, and here binomial approximation, and sin x expansion, and here down what it is present? It is present sin square x into x square. So I can take x into sin square x, so I can take x square into x square, and I can, when limit is extending to 0, this thing completely I can rub and write as 1 into 1. So it will be completely x cube. So that is the reason I changed the denominator. So like this, you have to take the approximations as well as applying the expansions when the 0 by 0 rationalization, factorization, L'Hopital fails. They are not failing, but there are those are lengthy processes. That is the reason I avoid applying those methods. The first question is completed. First question is completed. Now second question. First question completed. Now second question, limit. These are all JEE Advanced previous year questions. JEE Advanced Pyq's. Limit extending to 0, sine of pi into cos square x divided by x square equals to, and options are A, B and a C and a D. It is minus pi, it is pi, it is pi by 2, it is 1. This question is also very simple. Limit extending to 0, this is like this. So here if you observe carefully, it is sine of pi into cos square x. So what I can do, I can take limit extending to 0, sine of pi into, I can write cos square x as 1 minus sine square x. Yes, it is correct. Yes. Limit extending to 0, sine of pi minus pi sine square x. Yes, it is correct. I just multiplied it, pi into here and here divided by x square. Now limit extending to 0, it will be sine of pi minus something. What is sine of pi minus something? It is sine something, that is sine of pi sine square x divided by x square. So x is tending to 0, this complete thing is tending to 0. So what I can do, I can replace this x square here and I can write pi into sine square x, this box here same, and I can multiply the same box. Why I am doing this? Because we know when x is tending to 0, sine box divided by box is 1. So I can completely change this as 1, and finally what it is left, limit extending to 0, pi into sine square x divided by x square, and again another box, pi into sine x divided by x whole square. And when x is tending to 0, sine x by x, this box is 1. So this complete thing is 1. What it is left? Pi into 1. So it will be pi. Like this you have to solve. This box, limit x tending to 0, sine box divided by box equal to 1. Box can be anything, but box should be tending to 0. Here box is tending to 0 when x is tending to 0, because when x is 0, this box is pi into 0, it will be 0, it is tending to 0. And again here when x is 0, sine box, that is x is tending to 0, so it will be sin x by x, and when x is tending to 0 and sin x by x is equal to 1, this can be equal to pi. So option B is correct. Like this you have to do. Second question completed. Now third question. Now third question. The integer n for which limit x tending to 0 cos x minus 1 into cos x minus e power x divided by x power n is a finite non-zero number is option A, option B, option C, option D. 1, 2, 3, 4. A1, B2, C3, D4. So the options are also very interesting. If you observe carefully the question, what they are asking, the integer n, they are asking what is integer n. We don't know integer n, we have to find the integer n for which this complete thing is a finite non-zero number. This complete limit, when we evaluate, it should be finite non-zero number. So I am solving this first. Limit x tending to 0 cos x minus 1 into cos x minus e power x divided by x power n. Yes. Now if you observe carefully, if I can take minus common here. Limit x tending to 0, if I take minus common here, 1 minus cos x here, and I can multiply this minus into inside of second bracket, so it will be e power x minus cos x divided by x power n. Now if you observe carefully, in the top it is x is tending to 0. We know one property, that is limit x tending to 0, 1 minus cos x divided by x square equal to 1 by 2. So what I can do here, limit x tending to 0, 1 minus x square by x square, 1 minus cos x divided by x square equal to 1 by 2. I can simply divide by x square here and multiply by x square here. So this complete thing can be now 1 by 2. So limit x tending to 0, 1 by 2, 1 by 2 I can take outside of here, 1 by 2 into x square into e power x minus cos x divided by x power n. So if I divide here, it will be n minus 2. Yes, it is correct. 1 by 2 limit x tending to 0, e power x minus cos x divided by x in x power n minus 2. Now what we can do? If now it is 0, it will be again same thing. So now what we can do? It is now 0 by 0 form. I can use L'Hopital. Applying, wait, I will write here. Applying L'Hopital rule. L'Hopital rule. L'Hopital or L'Hospital? I don't know. L'Hopital, we say like this. So it will be half. What is L'Hopital says? Differentiate numerator and differentiate numerator and denominator differently, not by combining. Just differentiate individual. E power x minus cos x. It is e power x minus cos x. What is differentiation? It will be plus sin x divided by, here it is n minus 2 into x power n minus 3. Now if you apply now 0, this thing is 0, sine part is 0, but here cos part is 1 here, cos part is 1 here. Now finite non-zero number. So in order to be finite non-zero number, this thing should be 0. So n minus 3 equal to 0, n equal to 3. So by using n equal to 3, we can able to get the required result. That is, suppose it is 1 by 2. If n is 3, it is that is 1 into 1. So the final answer is 1 by 2 into n minus 2. So when it is n equal to 3, it will be 1 by 2. So it is a finite non-zero number. So it is correct. So n equal to 3 is correct. Wait, I will check the answer. Yes, correct only. So like this you have to do. You have to apply the first formula here. 1 minus cos x divided by x square equal to 1 by 2. You have to replace like this. And after that, you can take L'Hopital rule and you can differentiate the numerator and denominator individually, and you can find at what integer it is happening. Here, what integer it is happened? X power n minus 3. This numerator is safe. It is not a non-zero. So the denominator should be not equal to 0. So x power n minus 3 should not be equal to 0 when x is tending to 0. How it is possible? This term should not be present. So n minus 3 equal to 0. So n equal to 3. That is a reason why the answer is n equal to 3. The third question completed. Now fourth question. If limit x tending into infinity x square plus x plus 1 divided by x plus 1 minus ax minus b equal to 4, minus a minus b equal to 4, then now options, option A, option B, option C, option D, a equal to 1, b equal to 4, a equal to 1, b equal to minus 4, a equal to 2, b equal to minus 3, and a equal to 2 and b equal to 3. These are the things. Very important question. This is another model. Up to now we discussed the limit extending to 0. Now we are discussing limit extending to infinity. What I said in the change makers batch when I am discussing limits chapter, I said when limit x is tending to 0, we have to do one substitution, that is x should be 1 by 2 and limit t tending to 0. This is a substitution we have to do. So limit t tending to 0, we have to replace x as 1 by t. So 1 by t square plus 1 by t plus 1 divided by 1 by t plus 1 minus a by t minus b equal to 4. So it will be 1 plus t square divided by t square divided by 1 plus t divided by t. It will be t divided by 1 plus t. So what it will be? It will be t square and it is t cube, and here it can be multiplied by 1 plus t minus a by t minus b. This is a complete thing. This thing is equal to 0. Understand? And now limit t is tending to 0. So when now we have to take the LCM. We have to take the LCM here. What is LCM? The LCM is 1 second, guys. 1 second. This thing I am going to write another time. 1 plus t square divided by t square here divided by 1 plus t divided by t. It will be t divided by 1 plus t. T will get cancelled. No, sorry. It will be same. 1 plus t square only. Here it is t only. So what is LCM? T into 1 plus t. LCM is this thing. So the upper part is same. Here it is a into 1 plus t. And here b into t square plus t. This thing is equal to 4. I am updating this thing, but these conditions are very important. I will write here. Limit when limit extending to infinity, we have to substitute x equal to 1 by t and t should be tending to 0. This is the limit t tending to 0. I am rubbing this. Now here I am again repeating limit t tending to 0. Limit t tending to 0. Now if we observe carefully, here from this what we can do? 1 plus t square minus a into 1 plus t minus b into t square plus t divided by t into 1 plus t is equal to 4. I am rubbing this. Now if you observe carefully, I can separate out things. That is, here I can do? I can take t square as common. T square is common, 1 minus b here. And if I take t as common, 1 minus a minus b. If I take common t and if I take the constant terms 1 minus a, these things, and this entire thing is divided by 1 plus t. This thing is equal to 4. Now if you observe carefully, when t is tending to 0, this thing is 0, this thing is 0, this thing is 0, but it is not equating to 0. But the limit is existing, so it should be 0 when x is 0. So 1 minus a equal to 0, so a is equal to 1. One thing is completed. We find a. So now I can replace a. When a equal to 1, this thing is 0. and when a equal to 1 this thing is 0. So simply here it will be minus b into t. Yes. Now I can take common here t. When I take common here t, what it will be? It will be t into 1 minus b divided by, it will be 1 plus t, and when t is tending to 0, I am applying t equal to 0, this thing will be cancelled, and minus b it will be, and minus b equal to 4, so b equal to minus 4. So a equal to 1, b equal to minus 4. So option B is correct. Like this you have to do. 4 questions completed. Fifth question. Let alpha comma beta belongs to R be such that limit extending to 0 x square sine of beta x divided by alpha x minus sine x equal to 1, then 6 into alpha plus beta, what it is? Very simple question, but it is a JEE Advanced question. Let alpha beta belongs to R. So alpha beta belongs to real numbers. Okay. Be such that they given this relation, limit extending to 0 x square into sine of beta x divided by alpha x minus sine x. So you can observe carefully, in the numerator it is the product and x is tending to 0. When x is tending to 0, sine beta x, this beta x tending to 0. So what I can do? Limit extending to 0 x square into, I can write this as beta x divided by beta x into beta x, and here it is alpha x minus sine x, I can write. And when x is tending to 0 and this beta x tending to 0, this complete thing is equal to 1. So limit extending to 0 x square into beta x divided by alpha x minus sine x. So limit extending to 0 beta x cube divided by alpha x minus sine x. Understood? Now it is 0 by 0 form. What I can do? I can now apply L'Hopital rule, because it is 0 by 0 form. So it will be 3 beta x square divided by alpha minus cos x, and also here limit is tending to 0. Now when limit is this should be equal to 1, they given. When limit is tending to 0, numerator is 0, but denominator, if you see, when x is tending to 0, this thing is equal to 1. It is not equating to 0 denominator. In order to make the limit a finite value, it should be equal to 1. So in the top it is 0 divided by alpha minus 1. This alpha minus 1 should be equal to 0. So 0 by 0 it will be there. So alpha minus 1 equal to 0, alpha equal to 1. So 1 value we find it. So I can replace here 1. Now what we can do now? We can again differentiate. When we again differentiate extending to 0, now it will be 6 beta x divided by plus sine x. So we already know when x is tending to 0, x by sine x equal to 1, and the final answer is 6 beta, and the given this 6 beta answer is equal to 1. So what it will be? Beta equal to 1 by 6. What they are asked? 6 into alpha plus beta. What do we know? 6 into what is alpha? Alpha we already know, alpha equal to 1. Alpha equal to 1 I already said. Here when we differentiate it will be 3 beta x square divided by alpha minus cos x. When x is tending to 0, it will be 0 divided by alpha minus 1. So it should be equal to 0, alpha equal to 1. Like this I already explained before, alpha equal to 1. So 1 plus, what is beta? 1 by 6. So 6 into 7 by 6. 6 1 is 6 plus 1, it is 7 by 6. 6 6 cancel. So answer is 7. So like this you have to do. The total answer now is 7. Like this you have to solve the limits question. The fifth question completed. Now sixth question. Sixth question. Let M and N be two positive let m and n be two positive integers greater than 1 if limit alpha is tending to 0 e power cos of alpha power n divided by alpha power m equal to minus e by 2, then the value of m by n is, this is also simple question guys. What they given, let m and n be two positive integers which are greater than 1. What they are saying, if limit alpha tending to 0. So what I said to solve any question in limits, we have to find the what is the form of the limit. Where alpha is tending to 0, it will be cos 0 is 1, e minus c, it will be 0 divided by 0. So it will be 0 by 0 form. What I can do, I can simply differentiate this applying L'Hopital rule, because it is 0 by 0 form. Understand? Limit alpha tending to 0. If I differentiate this, e power cos of alpha power n same into cos of alpha power n, it is minus sin alpha power n. What is alpha power n? It will be n into alpha power n minus 1. This minus e, it will be 0 differentiation divided by m into alpha power n minus m minus 1. If you observe carefully, here alpha power n minus 1, here it is alpha power minus 1. So simply what I can do, I can cancel minus 1 here, because it will be definitely cancelling, because alpha power n divided by alpha, alpha power m divided by alpha, it will be alpha cancel, so it will be alpha power n divided by alpha power m, like this. Now we have to think what we can do. Now we have to again, if we substitute again 0, it will be minus c, it will be 0, but here it is also 0. Now we have to think in another way. What they asked m by n, here we got n by m. This m and m are the constants, so we can take outside. N by m we can take outside. Limit alpha tending to 0 minus e power cos of alpha power n into sin alpha power n into alpha power n divided by m into alpha power m. Yes? And now what we can think? And now when alpha is tending to 0, I can make this entire thing, that is sin alpha power n divided by alpha power n into alpha power n. So it will be completely changed, and alpha into alpha power n, it is alpha power 2n. Understand? Alpha power 2n, and when alpha is tending to 0, the complete thing is equal to e. So it will be completely minus e into alpha power 2n divided by m into alpha power m. So now again, when alpha is tending to 0, this complete thing can be equal to 1, because those are constant. So n by m, and here it is minus e into minus e equal to what they given, it is equal to minus e by 2. So minus cancel, e cancel, n by m equal to 1 by 2, and what is m by n? It will be 2, reciprocal. So the final answer is 2. Like this you have to do. 6th question completed. Seventh question. The value of limit x is tending to 0, 1 by x cube integration 0 to x t into ln of 1 plus t divided by t power 4 plus 4 dt is option A, option B, option C, option D 0, 1 by 12, 1 by 24, 1 by 64. So listen carefully guys. So if you observe carefully, what they given, they asked the value of limit extending to 0 1 by x cube into integration of t into ln of 1 plus t divided by t power 4 plus t. When x is tending to 0, if you observe carefully, this thing is 0. This integration 0 to 0. Anything integration a to a, it will be 0 only. So this part is 0, and this part is simply divided by x cube here. So this is also 0. So what is the form here? 0 by 0 form. So if it is 0 by 0 form, I can apply the L'Hopital rule. So applying L'Hopital rule, we get, why we are applying L'Hopital rule? Because this form is 0 by 0. If it is 0 by 0, we can apply the L'Hopital rule. That is the main reason I am applying the L'Hopital rule. I can apply. This is not only the way I can use the rationalization, I can use the factorization, but here the rational terms is not there. That is, root terms is not there. So I cannot use the rationalization. I cannot use the factorization also because there are no factors. So I am using the third method, that is L'Hopital rule. If L'Hopital rule is also difficult to use, I can use another method. There are many methods to solve the question. Applying L'Hopital. What is L'Hopital rule saying? L'Hopital rule saying differentiate numerator and denominator differently. That is simultaneously, but with, individually we have to differentiate. So limit extending to 0, we have to differentiate upper part. What is the differentiation of the integration? We already know the Leibniz rule. What is Leibniz rule? Leibniz rule is, suppose we have to differentiate like this, 0 to x, suppose h of x dx, if it is present like this, suppose h of t dt, if it is present like this, what I can do? I can simply differentiate like this, h of x into d by dx of x minus h of 0 into d by dx of 0. Like this I can do. Same method I am applying here. Limit extending to 0. Here it will be x into ln of 1 plus x, and a differentiation of x is x only, that is 1 only, into 1. So it will be 1 divided by 1 second. Here it will be x power 4 plus 4, and after it will be 0. The differentiation of 0 is 0, so I cannot, there is no need to do that. And here it is x cube. X cube differentiation is 3x square. Yes, have you understand? And next, 3x square divided by 1, it will be into 1 by 3x square, like this. And again limit extending to 0. Now we have to think what we can do. This x and this x is cancelled. Yes, and here it is 1 by 3, I can take outside. So there will be only simple x. What is limit extending to 0 ln of 1 plus x divided by x? 1 plus x divided by x. What is this? When x is tending to 0, it is 0 divided by 0. So 1 by 1 plus x here divided by 1. So it will be 1. So this complete answer is 1. So if you observe carefully, this thing I can write like this. Ln of 1 plus x divided by x into 1 by x power 4 plus 4. So ln of 1 plus x divided by x, it is completely 1. This thing is 1. So 1 by 3 into, when x is 0, this thing is 0. So 1 by 4. So into 1 into 1 by 4, it will be 1 by 12. So what is answer? 1 by 12. So option B is correct. Like this you have to solve. You have to use the identities. You have to use the first L'Hopital rule, and there is one form. And after that you have to see here. Here it is ln of 1 plus x, and here it is x. So ln of 1 plus x, and here it is x. I can make the form ln of 1 plus box divided by box, and limit box tending to 0. When x is tending to 0, this x tending to 0, and this box is tending to 0. This box is tending to 0, this box is tending to 0. This complete thing is equal to 1. So I can replace it as 1, and here it is x power 4, and when x is 0, it will be 0, and here it is simply 4, and I can take this is constant outside. So 1 by 3 into this thing is 1. Limit it now, it is completed. 1 by 3 into 1 into 1 by 4, it will be 1 by 12. Understand? Here it is limit, but here it is not limit. 1 by 12 is the answer. 7th question is completed. Now 8th question. Now 8th question, let L equal to limit extending to 0 a minus root of a square minus x square divided by 4 divided by x power 4 and a is greater than 0 if L is finite, then a equal to, option A they given as a equal to 2, B a equal to 1, C L equal to 1 by 64 and option D L equal to 1 by 32. This question is also very interesting. Maximum possibility is limit x tending to 0 questions only in JEE Advanced and JEE Mains, maximum. But there are chances, 5 to 10% chances are there to get infinity, limit extending to infinity or limit extending to minus infinity, like this forms. But it is not dependent on the problem. Limit extending to 0 may be there, but this thing can be anything. It can be 0 by 0, it can be infinity by infinity, it can be infinity minus infinity, it can be 0 by infinity into 0, it can be infinity power 0, 0 power 0, 1 power infinity, anything it can be. Depending upon this form you have to choose, not depending on this. Here why they given? To check the indeterminate form they given extending to 0. Not this is the process, when extending to 0 it can be 0 by 0, it can be infinity by infinity, anything. You have to check, after checking you have to do the process. Which process? If it is 0 by 0 or infinity by infinity, it can be rationalization or factorization or L'Hopital, or it is infinity minus infinity or 0 into infinity, we have to convert into these two things. And if it is infinity power 0, 0 power 0, we have to use ln, that is log, on both sides. And if it is 1 power infinity, we have to convert the whole limit into like this, e power f of x minus 1 into g of x. We have to convert like this. When f of x minus 1 into whole power g of x, if it is present, limit extending to 0. Suppose if it is like this. If it is like this, when x is tending to 0, suppose f of x equal to 1 and it is infinity, 1 power infinity form, we have to convert like this. F of x minus 1 into g of x, and it is e power. And now if we check here, when we check here, when is x is tending to 0 and when we substitute here, it will be a minus root of a square minus 0 minus 0 divided by 0. So it will be a minus 0 divided by 0, it will be 0 by 0. So 0 by 0 form is there. So there is a possibility of doing the three processes, that is L'Hopital, rationalization and factorization. The root terms is there, but it is not in a multiplication form, it is divided form. So it is not suitable. So I can use L'Hopital. Applying L'Hopital rule, we get limit x is tending to 0, which is constant 0 minus 1 by 2 root a square minus x square into, what is the differentiation of minus x square? It is minus 2x, and minus 2x it is minus 2x. Forget this minus. What is root of a square minus x square? Differentiation 1 by 2 root a square minus x square, and minus x square it is minus 2x, and minus 2x is minus 2. It will be 4x divided by 2 root a square minus x square, it will be 2x. 2x, wait guys, I am checking whether this differentiation is correct or not. Yes guys, minus 1 by 2 root a square minus x square into minus 2x into 2. Differentiation of 2x is 2. So now these two will get cancelled. So the complete thing is here I can write as 2x divided by root of a square minus x square, and here it will be minus 2x divided by 4. So it will be x by 2 divided by, here it is x power 4, it will be 4x cube. And if you take x as common here, limit extending to 0, if you take x as common, 2 divided by root of a square minus x square minus 1 by 2 divided by 4x cube. This x and this 3 terms will go cancel and it will be x square. Now we have to check again. Limit extending to 0. This thing is 0, but this thing should also be equal to 0. So 2 divided by root a square, it will be a. When x is tending to 0, it will be a. 2 by a minus 1 by 2. It should be equal to 0. So 2 by a equal to 1 by 2. A equal to 4. A equal to 4. Why I got a equal to 4? 1 second, guys. Sorry. Here it is. 1 second. One second, guys, there is a slight error. Is equal to okay. Yes, it is correct. A should be equal to 2, I think. Wait, I will check. Yes, A equal to 2, but I am getting A equal to 4. Where I had done mistake? Wait, guys, I will do again this. Limit extending to 0. This is constant. Here it will be 1 by 2 root a square minus x square, and minus x square, it is minus 2x. Root of a square minus x square plus c. Yes, it is correct. It will be like this: x divided by root of a square minus x square, it is minus 2x by 4, it will be x by 2 divided by 4 into x cube. Yes, and here x here 2 times, here x is cancelled. Limit extending to 0, 1 divided by root of a square minus x square minus 1 by 2 divided by 4x square. Now this is denominator is 0, we have to check the numerator. 1 divided by root of a square minus 0 minus 1 by 2, it should be equal to 0. 1 divided by a minus 1 by 2 equal to 0. 1 divided by equal to 1 by 2. A equal to 2. Now it is correct. What is the mistake? I have 2 here before, but now I don't have 2. That means I have rubbed. It is not, I didn't rub. Here it is x only, because here the 2 present here and 2 present here, these both are cancelled. That is the reason here will be 1 and a equal to 2. The option A is correct. Now we have to evaluate the limit. Now what we done? A equal to 2. So it will be 4. 4. Now again I am differentiating. Limit extending to 0. Extending to 0, it will be 4 minus x square whole power minus 1 by 2. It will be 0. Here it will be 8x. And here minus 1 by 2 into 4 minus x square whole power. It will be minus 3 by 2. If we differentiate this and multiplying, 4 minus x square differentiation is minus 2x and 2x differentiation is 2. Yes. So what you will get? This 2 will get cancelled. So minus 2x divided by 4 minus x square whole power 3 by 2 we will get. This complete thing, this complete differentiation is this thing. This thing. So this thing divided by 8x. So it will be 1 by 8x. So it will be 1 by 4. So it will be 1 by 4. Now when it is 1 by 4, I can take outside 1 by 4. And when I substitute x equal to 0, what it will be? 1 divided by 4 power 3 by 2. What is 4 power 3 by 2? 4 cube it is 4 4 16, 16 4s 64, 64 root it will be 8. So 1 by 4 into 1 by 8, what it will be? 1 by 32. So answer is D. L equal to 1 by 32. Like this you have to do. How many questions we got completed? 1, 2, 3, 4, 5, 6, 7, 8. 8 questions we completed. Now 9th question. Let alpha be a positive. Let alpha be a positive real number. Let f maps R to R. Let f maps R to R and G maps alpha to infinity. Alpha to infinity, G maps alpha to infinity, this is infinity tending to R, be two functions, be the functions defined by f of x equal to sine pi x divided by 12, this is one thing, and g of x equal to 2 log root x minus root alpha base e divided by log of e power root x minus e power root x root alpha divided by base e. Now observe carefully, guys. This is the thing, and what is the question I forgotten? Then the value of limit extending to alpha plus f of g of x is what? This is the question. So basically what they are asking, then the value of limit, first of all I will explain. Let alpha be the positive real number. So alpha is a positive real number, mark the important points. Let f maps R to R. And G maps alpha to infinity maps are alpha G maps alpha comma infinity. This is domain and this is codomain. These two functions are defined like this. Be the function defined by f of x function is this and g of x function is this. Now what they are asking, then the value of limit extending to alpha plus f of g of x. So what I can do this, I can simply write f of limit extending to alpha plus g of x. I can write like this. So what is, so I can solve this later. I can solve this complete thing first, this thing. So I can write f of something this thing is this thing only. So limit extending to alpha plus this is g of x. So what is g of x? Limit extending to alpha plus g of x is 2 log root x minus root alpha base e divided by log e power root x minus e power root alpha base e. So when x is alpha, this thing is 0, yes, and when x is alpha, it will be again 0. Log 0 is not defined, that is infinity divided by infinity. So this is infinity divided by infinity. So what we can do? We can apply L'Hopital rule. So applying L'Hopital rule, what we will get? Limit extending to alpha plus, it will be 2 into 1 by root x minus root alpha. And what is root x minus root alpha? Differentiation. It will be 1 by 2 root x. Yes, understand? Now again divided by, what is this thing? When we differentiate it, it will be 1 divided by e power root x minus e power root alpha, and here it will be e power root x, and what is root x? Here it will be 1 by 2 root x. Same, this root x will get cancelled. Yes, understand? And next, now what it can be? It can be here limit extending to alpha plus 2 divided by root x minus root alpha divided by e power root x divided by e power root x minus e power root alpha, this thing. So when it is like this multiply, what it will be? It will be simply limit extending to alpha plus 2 divided by root x minus root alpha into e power root x minus e power root alpha divided by e power root x, like this. Now we have to check again. Here when it is 1 second guys. Here it is minus. Now we have to check again. I can write these two outside. Yes. Alpha 0 by 0 it is coming. What we can do? We have to solve this thing only. After this step, what we can do? Let it be. We can differentiate again. If we differentiate again, it will be limit extending to alpha plus, it will be e power root x into 1 by 2 root x, and it is 0 divided by, if we differentiate again here, root x minus root alpha into e power root x only, 1 by 2 root x again, this thing plus again e power root x will be like this only, and here it will be root x, it will be 1 by 2 root x only. Yes, and the remaining part is 0. Now from these two things, what we can take common? We can take common as 2 into limit extending to alpha plus e power root x into 1 by 2 root x, and here down we can take common e power root x into 1 by 2 root x. If we take common like this, it will be root x minus root alpha, root x minus root alpha plus 1. Now these two things will be cancelled, and when it is alpha extending to alpha, these two things will be cancelled, so it will be 2. Simply it is 2. Yes, understood? It will be 2. So complete this answer is 2. So now this what we kept, we have to keep the value of this complete thing. It is 2. So f of 2. What is f of 2? F of 2 equal to sine pi by 12 into 2. It is 2 1 2 6. It will be f of 2 equal to sine pi by 6. What is sine pi by 6? Sin pi by 6 is sin 30. Sin 30 equal to 1 by 2. 1 by 2 equal to 0.5. So this complete answer is 0.5. Like this you have to solve. The 10th question is not printed correctly in my paper. So I can share it in the Telegram group. So if anyone didn't join the Telegram group, join the Telegram group also. It is really important. And if you have any doubts, you can reach in the comment section, or you can reach in the Instagram handle. So that's it for this video, guys. And if you have any other doubts, you can reach me in the Instagram handle. And all the best for your exams, guys. Thank you.